video. In this episode, we are going to look at how we can do full computations on this particular problem. Right, let's dive into it. So here we have an exponential function which is 3 power x multiplied by a polynomial function which is x squared. And we have to integrate. What do? We are going to choose u to be x squared and choose 3 power x to be the v. Good, let's go. But objective wise, I would prefer tabular method, that is the DI method, which is going to be very easy. But for theory wise, you can choose the traditional method, which is the formula approach, and it's going to be easy as well. So let's go by the traditional method in here. So here, let's u equals x squared. So this implies that du is equal to 2x dx. Okay, so once we have that, we said the v should be equal to 3 power x dx. So integrating both sides, we know that the integral of an exponential function 3 power x is going to be 3 power x over ln 3. Good. So once we have this information, we go for our traditional formula, which is the integration sign, right? Is equal to uv minus integral v du. So we have this information, the parameters. So we go ahead, our u right here is s squared and our v is 3 power x over ln 3. Okay, minus integral v is 3 power x over ln 3. And the du is 2x dx. 2x dx. Okay, so let's simplify this. So we simplify this and we have x squared 3 power x all over ln 3 minus, this is a constant, this is a constant. So we bring minus 2 over ln 3 out. Then we have 3 power x, of course, x 3 power x dx. Okay, still we have x in it, so we have to go the second time, so by part again. Okay, so here u equals the x. All right, so once we have that, then we can see that our dv is equal to 3 power x dx. So integrate both sides and we have v equals 3 power x over ln 3. So once we have these informations, we have in our mind that we are going to quote our formula again within this premises or within this argument. Okay, so we're going to have integration sign s squared 3 power x over ln 3 minus 2 over ln 3 integral x 3 power x dx. We quote our formula again for this, and that is going to be I equals s squared 3 power x over ln 3 minus 2 over ln 3. Then this is going to be uv minus integral v du right here. So we replace all this by the formula again. Okay, once we do that, we know that we have this information here to be x, we have the v to be this right here. So we substitute and do the necessary over there. So here we're going to have s squared 3 power x over ln 3 minus 2 over ln 3 into u, which is x, and v is 3 power x over ln 3 minus integral v, which is 3 power x over ln 3. Then our du is dx. Our du is this, dx. Okay, so let's do the necessary simplification. So we have s squared 3 power x over ln 3 minus 2 over ln 3 into x 3 power x over ln 3 minus, we have 3 power x over ln 3, and 1 over ln 3 is a constant, so we factor it out so that we can integrate the 3 power x. So when we do that, we are going to have 1 on ln 3 out, then integral 3 power x dx, right? So we're going to have I equals s squared 3 power x over ln 3 minus 2 over ln 3. Then we have into x 3 power x over ln 3 minus 1 over ln 3 into 3 power x. When you integrate it, you have 3 power x over ln 3. Then plus our constant of integration. So we simplify this, and then we have our integration to be equal to s squared 3 power x over ln 3 minus 2x 3 power x over ln 3 all squared, because we have ln 3, right? Minus, this is minus and this is minus with positive. So we have plus 2 over ln 3 all squared times 3 power x over ln 3, right? Plus our constant of integration. So let me write this final answer at this section for you, okay? It's so interesting, right? Very, very interesting. So once we have the final answer to be x squared 3 power x over ln 3 minus 2x 3 power x over ln 3 all squared plus 2 plus 2 times x 3 power x over ln 3 all power 3 plus our constant of integration. So this we have right here is our final answer for this particular integrand. So this is basically the final answer for this particular integrand. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'll give you more updates. Bye-bye.